Inside every mouthful of feed your animals consume is a complex set of nutrients, all designed to optimize the performance and health of beef and dairy cattle. Among those nutritional components are trace minerals, nutrients required in very small amounts to support vital biological processes. Although they're measured in parts per million, trace minerals significantly impact productivity and immunity. Feedstuffs do contain trace minerals, but the concentrations of many of these minerals typically aren't high enough to meet the nutritional demands of modern animal production. That's why producers and nutritionists supplement trace minerals in beef and dairy cattle diets. There are several trace mineral options available, and they vary both in effectiveness and cost. This program will explore how different sources of trace minerals behave so you can better understand how to choose the right trace minerals for your nutritional program. Let's start with a brief overview of what trace minerals are and what they do. Trace minerals support an array of biological functions that are required for proper immune function, reproduction, and growth. The most commonly supplemented trace minerals for cattle are zinc, which contributes to making protein, vitamin A utilization, fertility, and skin health. Manganese, which contributes to healthy bone and cartilage, enzymes, immunity, and fertility. And copper, which supports bone joint health, blood cells, immunity, fertility, and proper iron metabolism.
It is necessary to supplement trace minerals in beef and dairy diets because usually there's one or more trace minerals that are deficient in the natural feed ingredients. So unless we supplement what's naturally present in the diet, we're likely to run into deficiencies. Little is known really about the actual bioavailability of most trace minerals that occur naturally in feedstuffs. There's three major sources of trace minerals that are added to diets today. One would be inorganic trace minerals. The main ones that would be added would be sulfate forms. These are water soluble, they have a very weak bond, and they tend to be converted to the ionic form very easily. On the other hand, organic trace minerals would be another category. These are trace minerals that are chemically bound through covalent bonds to either carbon groups or amino groups, and these are usually considered more bioavailable because the mineral is not being as easily converted to the ionic form. Then the third type would be the hydroxy trace minerals, which is the most recent category. This group has covalent bonds, but instead of carbon, it's with hydroxy groups in chloride. These minerals also are not water soluble, but in the acid environment of the gut, they do start becoming soluble over time and converted to a form that can be absorbed.